Karen Crowther, welcome to Bendiksen Airways.
And thanks very much for having me.
Who are you?
I am an associate professor here in the philosophy department at the University of Oslo, and I work in the philosophy of physics.
I see. I've spoken to several physicists, both, the normal ones and quantum physicists, and they are all reluctant to answer my philosophical questions. So my question to you is, how is it possible to be a physicist and not at the same time be a philosopher?
Well, if you're speaking to experimentalists, that might be the problem, but definitely for theoreticians, I would say that philosophy is definitely hand in hand with the physics, and I think actually unavoidable in a way.
Yeah.
When you're working in physics, we have our theories, and you can think of the theories as having kind of the experimental, the data, the results in a way, numerical results. And then, of course, we have, the empirical results, and then we have the mathematical apparatus. But then how you connect that kind of mathematical apparatus to your actual empirical results, the things you're actually measuring, the things you're talking about, the real stuff in the world, you necessarily require an interpretation.
Yeah.
To explain how these parts of the theory relate to the world. And that is the philosophy, really. So a working physicist, they're always using some philosophy, they're always using some interpretation, whether they're realizing it or not. I think many of them, they come in and they're just using the one that they've been taught, or the one that everyone is using. It might be the most kind of practical one, the easiest one for them to work with, but it might not be the only one. There might be different ways of interpreting the theories. So doing philosophy of physics, part of it is kind of exploring these different interpretations of the theories.
Yeah. Your name came up when I was reading a series of articles in Quantum magazine about spacetime. Can you tell us about your article and what that was all about?
Yeah, I got an email from the Quantum magazine saying that they are doing a special issue on space-time emergence, which is exactly what I wrote my PhD thesis on a bit of a while ago now, but it continues to be a popular topic. The idea that maybe space-time is not fundamental in some sense, and that it kind of is an emergent entity in a way, entity or phenomenon.
Yeah. Just in short, emergence, what does it mean?
So it's this idea that something exists, but yeah, it's not fundamental. And then the question is, well, what do you mean by fundamental, right? So kind of at one kind of level of reality or at certain kind of scales, levels of description, maybe is a better way of putting it, something comes to be. So you can think about kind of, often it's spoken about in terms of consciousness as being emergent. So, we have this kind of collection of molecules and neurons at one scale when you're looking at kind of the smaller stuff. But then at a different level of description, you can talk about kind of the conscious experience, which, according to standard interpretation, isn't to be found in the neurons.
Yeah.
Or when you're talking about water, right? So water, when you're looking at it in the glass of tea, it's got certain properties. It's a liquid. It can be described by wave equations. It's continuous. It's wet. And so that's kind of at the emergent level of description. But if you were to kind of zoom in and look at it at a somehow more basic level, it's in terms of the molecules, and they don't possess on their own, when you're just looking at that level, they don't possess those properties that we find at the level where you're talking about water. So the idea of emergence is that many things at the kind of smaller scale come together. And when you look at them as kind of an aggregate, or we look at their kind of collective behavior, you're getting new kind of properties and a new description at that higher level. And that's the emergent level we're speaking about. So when we're speaking about emergent space-time, we're speaking about space-time at kind of the way we're speaking about it in physics now, that it exists. It has these certain properties, such as being a continuum, such as, having these wave equations according to general relativity, a particular dimensionality. It has all these different properties, but the idea is that at some more basic level, these aren't to be found there. So analogous with the water, maybe there's some sort of atoms of space-time that are themselves not in space-time, they're not spatiotemporal, but somehow they come together in such a way as to kind of produce space-time at the level of description where we know that space-time exists, where it's a useful concept for us.
Okay.
Hopefully that makes sense.
I read there's a website called Less Wrong. I don't know if you heard about it. I think it's Eliezer Yudkowsky who started it. One of the top AI guys. And I read one of his articles on where he was having a discussion about emergence, and his view on it was that it's just another way of saying that we don't know how things come to be.
No, I wouldn't put it that way.
No.
I don't think emergence has to be something spooky. I think when philosophers speak about emergence, they kind of have this notion of that it has to be something spooky, that it has to be kind of these new properties that come about at one level, or new laws, or new behaviors that cannot be explained by the more basic laws in a way. But I don't think it has to be that way. I think you can have a fully kind of so you might not have the explanation at this kind of more basic level, but then you're able to tell a story about how the higher level emergent stuff comes about. You can, in some cases, be able to tell the story about how these lower level entities come together to produce the higher level behavior. I don't think it has to be something mysterious.
No, I think his point was that if you have something that you don't know why it acts like it does, he says that emergence is just a way of breaking down into smaller parts and saying what it consists of, but you don't know why it, in the end, emerges as it does, I guess. I think that was his point. You spoke about theories, and there are a lot of theories in physics. What do we actually know?
Yeah, so this is quite interesting question. So we suspect that space-time is emergent, but obviously, according to our best current physics, it's not. It just exists, and it's kind of taken as a primitive in a way. So we're seeking a more fundamental description of it. But it's been taking a long time. This search for quantum gravity, which is the new theory we're looking for. And physicists have been looking for this for 100 years now. And so there's different ways of going about it.
How does that look like?
Yeah, this is it. Yeah, I think there's been a lot of kind of theoretical ideas going in many different directions. So you might have people working on string theory or on loop quantum gravity, on causal set theory, non-commutative geometry. There's different ways of trying to construct this new theory, but we don't know if any of them are correct or even if any of them are on the right path. The problem is they haven't been fully developed and they're not testable. So we can't really say at this stage whether they're correct or not, or even if they're going to lead to something in the end. So it's a bit of slow progress, I would say, and this, I think, is partly why we turn to philosophy in these cases, because then maybe there's some fundamental assumptions that are going into these different approaches, and the reason why we're looking for these different approaches or this theory at all. Maybe, we need to re-examine what it is we're even doing, why we're looking for this theory.
Yeah. What do you think of Donald Hoffman's theories?
Oh, right. Yeah, you told me to look it up. I didn't get a chance to look it up. We might have to save this one for the next conversation.
Because his thought is that we don't see reality as it is, and he doesn't say, but he proposes that maybe consciousness is the fundamental thing, and that space-time is not fundamental.
Yeah, I haven't really looked into the consciousness aspect, but I've become more and more interested in it. So I'm doing philosophy of physics, and already people view this with suspicion because, the physicists, they kind of look at us in philosophy like, you don't know what you're doing. This is, not going to lead us anywhere. You're asking the wrong kind of question. And then the philosophers, kind of the regular philosophers, look at me a bit mystified, like, oh, you understand physics? They also think, we're not really getting at the right question. So doing philosophy of physics is a bit of, it's a bit of a strange field, being between philosophy and physics, kind of having both. And then people tend to think, oh, maybe you're doing something very metaphysical, a bit spooky. And especially when you're bringing in consciousness, then the physicists really get like, oh. So up until now, I've been kind of working on very closely with kind of the established physics and the way things are going. But now I'm thinking, maybe I've got the permanent job now. I can do something that's maybe a bit more adventurous, a bit more speculative, I'd say. Speaking about the kind of quantum aspects of consciousness, and I'm becoming quite interested in kind of, these spatiotemporal aspects of consciousness too, the kind of locatedness of our experiences. And especially if we're thinking that space and time are not fundamental, then kind of how do we think about the locatedness of consciousness? Obviously, that would not be fundamental either. So I think already this is kind of revealing, it depends where you want to kind of place the consciousness. I've only just started thinking about this. I don't have too much to say yet.
Is it right to say that quarks are the most fundamental things we have discovered?
So, in a sense of being kind of in this fundamental theory of the standard model of quantum field theory, which describes many different types of fundamental particles. And if you're thinking about quarks as not being composed of anything else, they're basic in that sense. But there's different ways of thinking about fundamentality. So it might not just be that they are basic in the sense of being kind of the smallest stuff or not being composed of anything else. You can also speak of it in terms of the theories. So if you have a theory that's kind of more general, if it's more encompassing than other theories, I think of that as a better way of thinking about fundamentality.
Okay.
So kind of on this view, we kind of think that maybe the standard model and the very framework of quantum field theory itself might not be fundamental, because we're looking for this new theory that's supposed to be somehow more unified, more encompassing, because it's not just kind of quantum description of matter, but also going to include a quantum description of space-time. And currently, in our theory, quantum field theory, space-time is used in the theory, but it's not described by the theory.
Okay.
So you just kind of specify we have this background space-time where the particles live and move around in, but that's not being explained. It's just being used by the theory, if that makes sense.
So what is the quantum field theory?
Yeah, it's basically it's a theory that is trying to bring together quantum mechanics and special relativity.
Okay.
So you go from speaking about kind of like particles to being kind of fields that exist everywhere in space-time, and then the particles are point-light excitations of those fields. So we have, for instance, the electron field, and that's everywhere, defined everywhere in the space. And then you're talking about kind of local interactions between these excitations of the particles.
Can anything happen in the quantum field?
Can anything happen? I mean, strange things happen. We have, the uncertainty principle, where the implication of this is that you can have things like virtual particles. So these ones, they really, you can't detect them in a way, but they come out as fluctuations in this field that can exist for a very short amount of time, and then they kind of pop back into the vacuum. So talking about this quantum field theoretic vacuum, it's not, it's the state of lowest energy, but
Okay.
things are still happening there. You get these little fluctuations. So it's kind of a bit of a sea of different things popping in and out of existence. But when you're actually working with, obviously you're detecting real particles and not these kind of virtual particles. Yeah.
So I guess what I'm asking, do you think we have free will? And that's why I ask, can anything happen?
Okay. So you're asking about the determinism.
Yeah.
So, of course, it depends on what you mean by free will. So obviously, we, at our level of description, where we're speaking about, people and objects, we don't need to use quantum field theory, right? So, we can use ordinary classical mechanics, Newtonian mechanics, describing car crashes and, what you're walking down the street and things like this.
Yeah.
And kind of at this level, the laws we use, they are deterministic in the sense that, if you know the laws and you know the initial conditions, so the state, you specify kind of the positions and momentum of all your particles, and then you feed it into the laws, and then you can work out the positions and momentum of the particles at any other time, right? When you move, so it's deterministic in that sense. It's giving you predictions, it's giving you unique predictions, and you know what's going to happen if you wind it forward, or conversely rewind it and see what happened in the past. At the level of quantum theories, they're a probabilistic theory, right? So it's not going to give you definite, you can't kind of look at it and say, where are these particles going to be in the future? Instead, you ask a different kind of question. You ask, what is the probability that I will find the particle with this position and momentum? And it will give you kind of the probability that you'll find it. So you ask a different sort of question. and get a different sort of answer. Many people think that you could, because of this, you can kind of find room for free will if free will is supposed to be that we can, that is open in some sense, right? That, our current positions in momentum do not fully determine everything that's going to happen in the future, that there's an element, left open.
Yeah.
Which does seem to be allowed by having this kind of probabilistic theory. But if this is what you mean by free will, it also it doesn't give you kind of the choice either, because it's, if you're going from deterministic to indeterministic and you end up with kind of randomness, that's not really what you mean by free will either, I would say. You want some control. And I don't think it's clear how you get from that quantum mechanical description to get some control over your own free will, if you're being kind of fundamentally described by quantum field theory as well. So yeah, I think kind of at the level that we are, at this emergent level of human beings, the appropriate description is in terms of kind of the classical theories.
Yeah. So if I take a practical example, I parked a couple of kilometers away and walked here today. It took me about 25 minutes. So that's what happened. But could I have parked 1 kilometer away and walked there? Could that have happened?
I mean, it could have happened, but the fact that it didn't happen means that it couldn't have happened. So we're thinking in terms of our theory of space-time, of, Einstein's theory of relativity. And this comes up already with special relativity, that you have to think about all of space and time as existing at once. So space-time, it's kind of given in a way. It's there and it doesn't change. So this is called kind of the block universe picture.
Yeah.
So you imagine if you were to take a kind of God's eye perspective on it and be looking at space-time, you see the whole of space-time, like looking down at a paper map and seeing kind of the spatial coordinates, but now you've got an extra temporal dimension, right?
Yeah.
And everything is moving through space and time, but it's mapped out already. So you can see the world lines or the paths that everything takes through space-time, but nothing is actually happening. Okay. So from our perspective within it, we kind of experience time as flowing, and because we kind of have this experience that we're going forward, that we're moving in space and we're moving in time. But from the perspective of relativity, it is already there. So you can say, just as Australia exists, you could have been, even though we're not located in Australia right now, it's still there.
Yeah.
And in the same way, all of time is there, even though when we happen to be located right now at a particular point of time, just as we're located in a particular point of space, the other times exist. They are there.
So they're woven into space-time.
Yes, exactly.
So my walk from my car to here, it's still there.
Yeah, exactly.
Yeah. And that also makes it possible to travel in time.
Yes, exactly. Because all of time exists, it's kind of there. Whereas if you're thinking about free will, you're kind of thinking, well, maybe the future doesn't exist yet, and so I can have the possibility of changing it.
Yeah.
But if the future already kind of exists in some sense, it's mapped out already what you're going to be doing in those times.
So you don't think there are three paths and you can choose one of the three. You will go the one that's already determined for you.
But I don't think it's really. I think the fact that you made the choice, obviously we have this experience of making the choice. You choose to park your car there.
Yeah.
I think that is free will. And I think it can still be like you made that choice. The fact that you were never going to make a different choice doesn't take away from the fact that it was still your choice. So I think we do have free will to this kind of they call it a compatibilist view, where it can still be accommodated with a deterministic universe.
Strange to think about. What is it that your work now is mainly focused on?
Yeah, so I started off with the PhD looking at quantum gravity. I should say a bit more about what this theory is. So, as I mentioned, it's a theory that doesn't exist yet. Physicists have been looking for it for a very long time, and it's supposed to be more fundamental than our current theories. So, to provide, on the one hand, currently we have, as I mentioned, Einstein's theory of relativity, which describes space-time and gravity. And then on the other hand, we have, as mentioned, the quantum field theory describing matter, the quantum nature of matter, which doesn't give us a quantum description of space-time. And yeah, it seems like we have these two different pictures of the world, and then we want something that kind of brings it together. We want something that gives us a coherent account,
Yeah.
rather than having, on one hand, a non-quantum space-time and quantum matter, and then on the other hand, we just have space-time and classical matter. And then it seems we need something to bring it together to get a quantum description of space-time. And
Is
then
that
we
also
have a
what string
coherence.
theory is supposed to do?
Yes,
Yeah. So
exactly.
these are competing theories.
So string theory is one way of approaching quantum gravity. So the label quantum gravity is supposed to refer to whatever theory it is that gives us this quantum description of space-time, I would say, in kind of the most basic terms. So string theory is one way of doing it, but there's other ways of trying to find the theory that are competing with string theory for this and doing very different things. So yeah, quantum gravity is kind of a label. It's just a kind of a placeholder for the theory we are looking for. And then there's different possibilities of what could actually satisfy this. And as we've been speaking about, many of these kind of approaches towards finding this new theory, although none of them are fully worked out, they're all kind of work in progress. Many of them are suggesting, and we have kind of other reasons by looking at our two theories now, that when you kind of quantize space-time or have a quantum description of space-time, it's not really space-time anymore. You're describing something more fundamental, some non-spatiotemporal thing that's supposed to underlie space-time, to describe kind of the atoms of space-time that are not themselves existing in space-time. So it's a very strange thing to try and picture, and I don't think we can really picture it.
Have you heard of Neem Arkani Hamed and his
Yes.
theories? So he says that he has, I don't know, found structures beyond space-time or behind, or what you call it.
Yes, exactly.
Like the amplituhedron and stuff.
Mm-hmm.
What is it?
Oh, yeah. Oh, it's been a while since I looked at his stuff. I mean, there's so many different ways of going about this, and attempts to find this new theory, all these different ideas. And I think this is really cool, yeah, let a thousand flowers bloom, try all these different things.
Yeah.
So this is it. I started off by looking at these different ways of approaching the problem, and I was doing kind of the metaphysics of quantum gravity. So looking at specific approaches, asking what are they actually saying is there, and trying to give kind of an interpretation of whatever these more fundamental entities are, and how we could, in what sense we could say that space-time emerges from those. So I was doing more of a metaphysical project, the ontological idea, what is emergence? How
Yeah.
can we understand emergence in this context? But as I went on, I realized this is a bit dangerous, trying to do metaphysics of a theory that doesn't exist yet. We don't know if any of these approaches are correct. I was really worried that I'm going to spend my life trying to interpret these theories and they're all just completely wrong. So then I shifted into the more epistemological question. So metaphysics, of course, is kind of describe what exists and the relation between what exists. And epistemology is a branch of philosophy that deals with kind of our knowledge. How do we know about what exists? What is knowledge? So the epistemological question I became interested in is, why are we looking for this theory in the first place?
Yeah.
So that's what I've been working on now. I've just finished a book manuscript for Cambridge University Elements. So it's a little book, hopefully out soon, probably next year. Just kind of asking, what is quantum gravity? Why are we looking for this theory?
Why are we?
Yeah, I think the main one is to have this kind of coherent picture of the world. We don't like having separate theories that are saying different things. We want, conceptual consistency in a way. So I think the main kind of principle that's driving this is consistency. So many people frame it in terms of unification, and I said unification before as well. But it doesn't have to actually be a unified theory that we're looking for. So to have a single theory that is consistent, that doesn't necessarily mean that it has to be a unified theory, even though we're trying to bring in these two different theories and make them consistent. To be unified is something stronger. So it's not just that we would have a single theory that describes everything. To have a unified theory would mean that we have this theory that describes everything, but it describes everything as being kind of the same. Everything stems from this one type of entity in a way. So you can think of electromagnetism. We had, this theory of electricity and magnetism, and we had the theory of light. And then Maxwell came in and showed that we can unify this in terms of an electromagnetic field. And then the very diverse phenomena we observe are actually due to kind of this one entity and its behavior, the electromagnetic field. So that's an example of unification. And in terms of the standard model of particle physics that I mentioned in quantum field theory, it describes many different types of particles, and it unifies some of them. We have to, it unifies the electromagnetic field with actually the weak nuclear force. So
why do we need a strong and a weak nuclear force? Isn't it just a spectrum of how strong?
Oh no, they're different interactions. Yeah. It's different interactions in the nucleus. I don't know why they have different names. So yeah, one is between the quarks and one is with the electron.
Okay.
Right.
Yeah.
Um,
And gravity is the big stuff.
well,
What binds the big?
Yeah, gravity, it should apply to anything that has mass.
Yeah.
So anything that has mass, so it's not just the big stuff. These tiny, tiny particles, they do have mass. It's just very small. So at that scale, you kind of use those other forces become stronger, and the gravity between them becomes negligible compared to the strength of these other forces. So you might think, yeah, if you're being driven by unification, you'd be wanting kind of a theory that describes everything in terms of one type of entity. It brings gravity and shows that it's just a manifestation of something more fundamental. Everything is a manifestation of something more fundamental that is kind of ultimately the same type of thing. String theory does this in a way, because it says, all these forces are just the vibrations of strings and their interactions and behavior of strings. So in a way that reduces it to one type of entity. But I think we don't need a theory that has to be unified. I think that's an extra assumption, and quite a strong one, right? It might be that we have a theory of quantum gravity that has different terms for space-time and gravity, and the other particles, without being a unified theory in this sense. So, I think unification is an extra assumption, which it has driven physics for a long time. I got quite curious about this, like why do we kind of seek more unified theories? And as you can tell, I'm being a bit kind of skeptical of it. But more and more I'm getting, maybe there's something interesting. I'm going back and forth here. I think it goes back to the ancient Greeks and Plato. They did have this kind of view of the universe where everything is one. So I think we're still working within that tradition to try and describe everything as one. Yeah. But this is kind of I'm going to explore this a bit more, I think. Yeah.
What about the maths or the mathematical models? How do they guide our perception of reality?
Yeah, so quite interesting, I think, how we're able to come up with these mathematical theories, and they work so well for describing reality. But then it kind of the world is actually much messier than what you realize when you take a physics degree, right?
Yeah.
Or you do high school physics. I felt very I felt very powerful when I started studying physics. Like, we can write down these beautiful equations, they describe everything. But then in reality, you're actually describing a very idealized case in a way. You have to, there's a high school examples where you have to, neglecting friction, calculate how far the car is going to roll before it smashes. So things like this, I think, the mathematics describes a sort of idealized form of, and then I think, again, kind of going back to the Plato, I'm becoming kind of curious about this, right? If it's describing kind of, we're using them to get predictions about what we observe, but then what is it actually describing? I think is quite another question.
Yeah. What do you think of the simulation hypothesis?
So do you want to say a bit more about it?
That we're living in a simulation. I think it was Nick Bostrom who first came up with it.
Yeah.
The Swede. So, and I've heard that people like Elon Musk support it, that they think we might be living in a simulation.
So a simulation, is it kind of a new idea? I mean, you go back to Descartes, who has this dream argument, right? Maybe we're really in a dream. Maybe we're being deceived by an evil demon, and all our experiences don't correspond to what's actually going on, that there is something more, I guess, lying behind the appearances.
The Matrix.
Yeah, in the Matrix. You can't use the Matrix in examples anymore in lectures, because like the students I'm teaching here, they were born after it came out. Someone needs to make a new movie for being up to date. Yeah. So I guess it would mean that there is some kind of higher power that is doing the deceiving, who's kind of built this simulation. I mean, is that what he says?
I guess it's that there's some alien. There's a civilization that's been so advanced that they can simulate an entire civilization.
Yeah. I mean, yeah, it is possible. This kind of thing you can't ever rule out. It comes back to this very basic problem of epistemology. You know, how do we know what's actually going on? We can only verify our experiences. We can't kind of step outside of, being sensory creatures. We're very limited. So it's something I think that, to be scientific, it needs to make some sort of predictions that we can test that would, kind of show, evidence of this. And I think the way it's been framed is almost like, how would we even do that? Could we, I don't know, maybe start by attempting it ourselves, build little simulations that become conscious? I don't know. So at the moment, I think, it's interesting philosophy. It's fun philosophy, but I'm not seeing how it's scientific or how we could ever determine this. Does he have suggestions?
The hypothesis is three arguments, and my memory is not good enough. It's one that either if the hypothesis is that if we are the only real civilization, what is it again? It's that either we are obviously the only real one, and it can then simulate others because we've become that advanced, or the other choose not to simulate, and the third one is that we are in a simulation because there are so many more advanced civilizations, and one would eventually choose to simulate another. That's not spot on, but it's something like that.
Yeah. It's a sort of argument. I think then it would be kind of interesting to ask, what are the other assumptions that go into that, right? I guess the spatiotemporal aspect is one of those.
Who knows?
I also like Max Tegmark. Have you seen some of his ideas about kind of different levels of multiverse? I think this is really fun as well. And maybe kind of, string theory describes the multiverse, right? Different, possible universes consistent with the theory, and then kind of where we are. It kind of explains everything in a way, because if we're curious about why our world is the way it is, it's like, well, there's all these other possibilities that exist, and so necessarily ours exists, and we find ourselves located in this one, this very anthropic reasoning. But then there might be kind of different levels of this. So Tegmark kind of really goes into Platonism, that maybe some ultimate level, everything is numbers, and numbers are what exist, rather than kind of the physical reality. I think they all exist, but have kind of derivative status of the way they relate to one another. And this kind of sounds to me a lot like the Neoplatonic kind of philosophy. So we're becoming more curious about this, tying back to what you said about what you asked about the mathematics, right? How does it work to explain our world? Well, maybe everything is just mathematics.
Did we invent mathematics?
Oh, yeah. You mean like invention versus discovery?
Yeah.
So I think Plato would say that when you are not kind of in our physical realm, so before you're born and after you're dead, you're just kind of part of the universe. And at that stage, you don't have this, physical element. You are kind of some sort of soul, I guess, or mind or consciousness, but you don't have any kind of individuality. You're just kind of one with the universe. And
I heard when you're talking about it, I heard a quote the other day. I can't remember who it was, but it says something like you didn't come into this world, you came out of it.
ah,
I guess that maybe relates a bit to what you just
yeah,
said.
that the physical is more kind of derivative from the kind of more fundamental
Yeah.
one. Yeah. Yeah, so when you're kind of at that level, you have all the knowledge there is. And then when you become born into the physical world, you kind of forget all of it, but it's still within you. And then he has this famous, you know, story where he's trying to demonstrate that when we learn mathematics, we're not learning it fresh. It's already within us. We just have to remember this. So in a way, I think, we invented it because it's a tool for us. It's our kind of way of describing the world and kind of making sense of it. Even kind of theoretical mathematics, pure mathematics, yeah. But it still might be grasping something else that exists independently of us, right? So maybe that's what you're thinking.
Yeah, I don't know what I'm thinking
I don't know what I'm thinking
anymore.
either. I think that just is quite interesting to explore.
Yeah.
Yeah.
What do you see as the future of physics?
Yeah. I mean, the way it's going now with quantum gravity, like I said, it's a bit stuck because we're not being driven by empirical problems. So normally, when you're looking for a new theory, it's because you've observed something weird that you can't explain with your current theories, or your current theories have made some prediction, and when you go out and try to look for that, you don't find it. So then there's a mismatch between your theory and the world, right? And this is about observation and experiment, which has always driven physics. But now we're looking for this new theory of quantum gravity. We're not being driven by these kind of observational problems. We're being driven by more kind of conceptual problems, more philosophical problems. And also, all the theories that we've come up with, they haven't made any predictions that we can go out and test yet. I'm not ruling out that they can't. I'm sure, if we work on them enough, hopefully they could.
Yeah.
But at the moment, and the way it's been going, it's become more and more kind of detached. So it's a bit of a turn in science, and makes you think, well, what is physics? Very theoretical physics. It should always still have this connection with observable phenomena, I think. So where it's going to go after this, I don't know. I think we need to kind of examine, as I said, some more basic principles that go into our physics and kind of find out what are we basing these on, Are they well-founded or not?
Yeah.
Maybe we can reconsider some of them or try different things.
So I think it's more rethinking conceptual foundations that exist rather than new empirical findings.
Yeah, I think so. And I think actually one of these big assumptions that most people are working with is that quantum is fundamental. We're looking for this quantum theory of gravity. We're seeking to modify space-time to make it quantum. But what if quantum theory itself isn't fundamental? What if there's something beyond that? And most people haven't been looking into that. There are some approaches like the information theoretic approaches, which are seeking to kind of find more basic principles behind quantum mechanics, some axioms from which we can get those. But those haven't been really looked at in the context of quantum gravity, as far as I know. So that might be one way it could go, a very probably unlikely one, the way physicists are working, but yeah, possibility.
Do you think we will ever find out what lies beneath or what is fundamental?
I think we can keep trying. Yes. Some nights I have a bit of an existential crisis staring out the window because, I do this because I am genuinely interested. I do philosophy not just as an academic exercise, but because I really want to grasp something of the universe. And then I'm thinking, this problem of epistemology that I mentioned before, that we can never actually know whether what we're finding is kind of real or not. I think we just kind of have to take it on faith. So I just have this belief that we are able to grasp something, even if we can never kind of establish it concretely. So I think it's an article of faith. And without that, I get very depressed.
Talking about faith, a lot of the physicists and people working on this, when I speak to them, a lot of them believe in God, whatever that might be. What do you think of that? When people working on these things have that belief?
Yeah, I think it's a conception of God where God is kind of the universe. I think, Einstein put it this way: I believe in the God of Spinoza. And I quite like this idea that, I think it's very kind of, what's the word? Hubris. If you're thinking that we are the ultimate creatures in a way, that there's kind of nothing greater than us. So I think we should think that there's, something beyond us, something greater than us. You can call it God, but just thinking of it in terms of the universe, rather than being a kind of higher power that's created everything. So kind of depends why or what you want this God to do. What purpose is it serving in your conceptual framework, I guess? Do they mean a creator God or a God that's kind of, testing us, very human interaction, or something else?
Yeah.
Yeah.
Do you believe in aliens?
Oh yeah, I really love thinking about aliens. When I was a kid, I was always watching X-Files.
Yeah.
And I think that is kind of what got me into wanting to study science as well. I think, I guess that goes back to what I'm saying, in a vast universe, why think that we are the only creatures that exist? No, I think that, there'll be other things out there, other life,
I have to ask about the observer and perception and how that, I've obviously heard about the double slit experiment. What is it exactly that the science says about things that change when being observed?
So there are different interpretations of quantum mechanics. And some of them make reference to the observer, but I think most of them try to avoid this. They speak about measurement instead, but I guess that's a bit of a synonym. So I think the problem is that when you're including the observer, it's not described by the quantum theory itself. And then if you want a quantum description of the observer, it becomes very messy. So then you get into a bit of trouble trying to work it out. So it depends on what interpretation you have, what role the observer is playing. Yeah, I'm not sure really. I'm kind of still exploring the different possible interpretation. I'm starting to look at the cubism, which does take puts kind of the observer in a central role. But yeah, I don't have much to say about it at this stage. Yeah.
Okay, just to finish up on the consciousness, like I was starting to say, Hoffman, he thinks that the human mind is just like a computer desktop, that if you have tools and we make use of them, but they're not fundamental, they're not real, we can't observe reality. Like I guess on a computer desktop it's just zeros and ones, but we see an icon, for example. And also, like I spoke about, that if we look away from an object we were observing, it ceases to exist. So he thinks that we create reality, basically.
But it's through our kind of sense
Yes.
perceptions. So kind of our physical, our sensory organs that
I obviously can't speak for him.
using them to kind of detect things. We're detecting other physical things. I'm touching the table. And you're saying if I'm not touching the table and I'm not kind of looking at it, it's not there. But then, yeah, it seems, so then the consciousness is the interface, but not the physical apparatus by which we're...
Yes.
So I think there's kind of different things that would need explanation there. How does it stay together in a way, I would say. It could be something like what I was saying with Plato, where kind of fundamental, kind of at one level there is just this unphysical, non-spatio-temporal being of mind or consciousness, which has no kind of physical characteristics, so no individuation. And yeah, and then how you get the physical out from that, you'd need some story, right? So if he's really placing observation at the center, observation does seem like a very physical process that we're privileging kind of our ability to detect things. Does he have an explanation of why?
I'm sure he does, but I'm not smart enough to tell you. You'll have to look into him.
Okay.
But I have one reflection I would like to share and hear your thoughts about you being a philosopher. I was talking with my cousin last night. We were looking at fundamental physics, quarks, neutrinos, etc. And like it says, quarks are the most fundamental. There's nothing inside them. That's what the Standard Model says. But if everything is made up of the same stuff, including us, we are thinking about these things with these things. What does that tell you?
Yeah. Are you pushing for like a panpsychism view here? It might be that kind of everything has this kind of level of consciousness. Maybe, but yeah.
It's just that how can we reflect on things that basically makes us reflect, if you understand what I mean? We are building block, or these are building blocks that make up humans as well as everything else.
Yeah, I mean...
And then we can reflect on this.
Yeah, we're just trying to understand what it is that we're made up of and what the universe is made up of, what the fundamental laws are, the fundamental constituents of reality. And maybe that could be, we're doing it from this kind of emergent level, right? It's not like it's just, a bunch of quarks in your lab. It's ones that have come together in a certain way through evolution to be human beings. So I don't think it's necessarily a problem because you can say the same thing about the spatio-temporal aspects, right? We are located in the universe. We're part of the universe. We can't ever step outside of it to get kind of this God's eye view, even though physics tries to do that, I think. You have to take into account the fact that we are situated observers. We're located somewhere in space and time. And we're limited in that aspect. So then, can we get at the fundamental stuff when we are so limited? We can't really get at stuff beyond us. We can, come up with our philosophical theories. We can do our best science. But to go beyond that, to know what's actually happening, can't really do that, I would say.
Last question. What's the meaning of life?
Meaning of life. Can I say the meaning of life is to find meaning? Yes, I would say so.
Thank you.
Thank you.
Tusen takk for at du hørte på Bendiksen Airways. Dersom du har tips, kommentarer eller vil gi en vurdering av episoden, så gjør gjerne det. Det setter jeg stor pris på.